Okay, rectangular coordinate system. I'm pretty sure you already know how to plot points, x on the horizontal, y on the vertical. The quadrants we call quadrant 1, 2, 3, and 4, just to help us tell where we are in a particular number plane. The formula for the distance between 2 points, I also think you've probably seen before, and it just comes from the Pythagorean theorem. If we're given 2 points, 3, 5, 7, 9, you can label the points to help you keep track of the different coordinates. What we're really doing here when we're taking x1 subtract x2 is finding the distance between the two x coordinates of the points. Which between 3 and 7, that distance is 4. The distance between the two y coordinates would be between 5 and 7 is also 4. And then 4 squared plus 4 squared, 16 plus 16, I guess is 32. So we're really just doing the Pythagorean theorem. This leg is 4, this leg is 4, a squared plus b squared equals c squared. So you can either memorize the formula, or you can just think of it as being a right triangle and using the Pythagorean theorem. The midpoint formula is really just the average of the x coordinates and the average of the y coordinates. Using the same 2 points, what we can do is add the two x values together, divide by 2, add the two y values together, divide by 2, simplify, and easy to do a quick sketch of the 2 points, 3, 5, 7, 9. Does it look like the point 5, 7 is halfway in between the 2 points, and that can help you catch those annoying little arithmetic errors we all make. The graph of equation in 2 variables, again, something I think you've seen before, and just a little reminder here to compare. 0 equals negative 2x plus 3 is an equation with one solution, whereas y equals negative 2x plus 3 is describing a relationship between two variables x and y. It's a function and it has many, many solutions. Here's just a few of them here. It's impossible to list all the solutions to this particular equation. And so what we can do is graph the various points along the function, and every point on this line is a solution to this particular equation. With linear functions, anything that's we can write in the form y equals mx plus b, 2 points are sufficient to sketch a solution set. That's always a good idea to do a third point just to check. For more complicated equations, you need more points to track the turns, and this is where your graphing calculator is so handy, because what it is doing is quickly plotting lots of points, and those points together are forming the graph of the line. And remember, you've got the table feature also in your graphing calculator to help you locate points. Okay, so here's the tricky part in section 2.1, the equation of a circle. And just note, circles aren't functions for reasons that we'll actually cover in the next section. The definition of a circle is the set of points that are fixed distance, called the radius, from one point that's called the center of the circle. So the center of the circle is a point, we call it the coordinates hk, and then the radius we denote with a variable r. So standard form is x subtract h squared plus y subtract k squared equals r squared, where again the center is hk, the radius is r. So if we're given this equation of a circle, the center of the circle is going to be at negative 2, positive 3. Now pay attention there to the h and k because it's x subtract h. X plus 2 is really x subtract negative 2, so the value of h is negative 2. And then y subtract 3 means that k is positive 3. A lot of students just think of this as it's the opposite. What happens if you set x plus 2 equal to 0, x equals negative 2? What happens if you set y subtract 3 equal to 0? You get y equals 3. So those are the coordinates. And then the equation of a circle equals a radius squared, so our radius would be 3. We can plot the circle, locate the center, negative 2, 3, and then count up 3, down 3, left 3, and right 3 from the center. Join them with the circle, and there's the graph of your line. Okay. Now find the equation of the circle with endpoints of the diameter. I think a sketch is really helpful. It's not technically necessary, but I find it really helpful to keep track of the information. So if we know the endpoints of the diameter at 5, negative 1, and 3, 7, that line joining those 2 points is the diameter, and the middle of that line is going to be the center of our circle. So we can use our midpoint formula, 5 plus 3 over 2, negative 1 plus 7 over 2, and that gives us the center of the circle, HK. That'll be the points 4, 3. And again, looking at our sketch, make sure it looks reasonable. The radius is half the diameter, so one way to find the radius is to take the distance between the two endpoints and then divide that by 2. So using our distance formula, 5 subtract 3 squared, negative 1 subtract 7 squared, simplifying, the distance is square root of 68, and that'd be the length of the line all the way across the circle, so the radius is half of that distance. And then putting that into our standard form, we know the value of h, we know the value of k, we know the value of r, and this simplifies quite a bit. When we square the 68 over 2, we get 68 over 4, which actually turns out to be 17. And so the radius of the circle is the square root of 17, which is about 4 point something or other. Okay, so the standard is the useful form of the equation of the circle. The general form is the unuseful form. So we're going to spend some time learning how to convert from the general form to the standard form for the equation of a circle. Those of you going on to trigonometry are going to see quite a bit of this, not only with circles, but with ellipses, parabolas, hyperbolas, and all sorts of good shapes. Okay, so what we're going to do is complete the square. And notice I changed my problem here. So this is x squared plus y squared, subtract 6x, subtract 4y plus 4 equals 0. Becomes that a little nicer than what I originally had there. What we're going to do is group all the x's together, group the y's together, and move the 4 over to the other side of the equation, so it's now a negative 4. To complete the square, we're going to find our magic numbers for the x's. Take the negative 6, half of it squared gives us 9, and complete the square for the y's. Negative 4 divided by 2 squared is 4, and we'll add those to both sides of the equation, keeping the equation balanced. Now we can factor the x's, giving us x subtract 3 squared, factor the y's, giving us y subtract 2 squared, and then over here on the right side of the equation, we end up with 9, which I'm going to write as 3 squared, so it fits that standard form. And then we can see the center of our circle is 3, 2, and a radius is 3. And here's another one if you'd like to look at it. Again, we're gather the x's together, the y's together, and move the constant to the other side. Complete the square for the x's and y's. Factor, get it in standard form. And then again, be careful with the center. The center of the circle is going to be at negative 4, positive 3, and the radius is the square root of 21.